This is the video on section 4-2, which is on completing the square. The key vocabulary in this section is completing the square. The essential question is, how do you solve quadratic equations using completing the square? Before we actually get into how to complete the square, let's talk about our square root property. Anytime you're solving a square root or solving a quadratic and you're taking the square root because you want x, not x squared, then when you take the square root of the number, you have a positive or a negative of whatever that number is. So if we look at our first example of 4x squared plus 11 equals 59, opposite of adding 11 would be subtracting 11, which would give us 4x squared equals 48. The opposite of multiplying by 4 is dividing by 4, so that gives us that x squared equals 12. So now we want x, not x squared. So now we have to take the square root of both sides. So when we take the square root of 12, we have x equals plus or minus the square root of 12. However, before you say that as your answer, you need to make sure that your radicals can't be simplified. Well, this one can be because 12 is 4 times 3. So our final answer would be x equals plus or minus 2 radical 3. On example B, we have x squared plus 12x plus 36 equals 28. Well, when I look at this left side, I realize that this is a perfect square trinomial. So this factors to x plus 6 squared equals 28. So we want x by itself, but since all of this is in the parentheses and squaring, we have to start by taking the square root of both sides. So this is going to just leave us with x plus 6 equals, again, because we took the square root, it's a positive or negative, square root of 28. Simplify your radical. 28 is 4 times 7, square root of 4 is 2. So that gives us x plus 6 equals plus or minus 2 radical 7. And then our last step would be to get the x by itself by subtracting 6 on both sides. So that gives us x equals negative 6 plus or minus 2 radical 7. And you can leave your answer like that. So let's look at completing the square. If a quadratic expression of the form x squared plus bx cannot model a square, you can add a term to form a perfect square trinomial. This is what we call completing the square. So these are some steps that we're going to take in order to complete the square. We're going to take our middle coefficient, which is our b term, and divide it by 2. Then we're going to take that answer and square it, and we're going to add it to the end of our expression. And then once we have it as a perfect square trinomial, we can factor it to whatever it would factor to. So example says complete the square and factor. So according to our steps, it says take your b term, and in this case is negative 6, divide that by 2. That gives us negative 3. Second step says to take that answer and square it. So negative 3 squared is 9. Then it says to take that number and add it to the end of the expression. Now this is a perfect square trinomial. So that would factor to something that looks like this. The sign in front of b is the sign that's going to go in the middle. Square root of x squared is x, and the square root of 9 is 3. Let's try another. On b, we have x squared plus 15x. So our b is 15, so we're going to do 15 divided by 2. Well, that's going to give us a decimal, and we don't want decimals when we're working with this. Leave them as fractions. So we're going to take that number and square it. So 15 squared is 225, and 2 squared is 4. So that becomes x squared plus 15x plus 225 over 4. Then when we factor it, the sign in the middle is going to be a plus because the sign in front of our b is plus. Square root of x squared is x. The square root of 25 over 4 is just 15 over 2. Solve by completing the square. Okay, so we're going to follow kind of the same steps that we just did. However, if you notice, now you have a c term that's also attached here. My suggestion is to go ahead and move the coefficient to the other side so that we now have x squared plus 6x equals 16. Now, just like we did before, you're going to take your b term, 6, divide that by 2, which we get 3. Take that number and square it, so we get 9. So now we have x squared plus 6x plus 9 equals 16. But our golden rule is always what you add to one side, you have to add to the other. So since we added 9 on the left side, you have to go back and add 9 to the right side. So now we have x squared plus 6x plus 9 equals 25. This is now a perfect square trinomial, so that factors to x plus 3 squared equals 25. And now you're getting x by itself, so you have to take the square root of both sides. So now I have x plus 3 equals plus or minus 5. You want x by itself, so the opposite of adding is subtracting. So now I have x equals negative 3 plus or minus 5. So now you have to break this up so that you see that you do have two answers here. You have x equals negative 3 plus 5, which tells me that x equals 2. And you have x equals negative 3 minus 5, which tells me that x equals negative 8. And these are your two answers. Let's try another one. So I have x squared plus 10x minus 24, and since it says solve by completing the square, I'm going to move the coefficient to the other side. So that gives me x squared plus 10x equals 24. Off to the side, I have my b, which is 10, divided by 2 equals 5. Then we're going to take that number and square it, which is 25. So that gives me x squared plus 10x plus 25 equals 24. I added 25 to the left, so I have to add 25 to the right. So now I have x squared plus 10x plus 25 equals 49. Now the left side is a perfect square trinomial, so we can factor that. That's going to factor to x plus 5 squared equals 49. To get x by itself, we have to take the square root of both sides. So I have x plus 5 equals, square root of 49 is 7, but it's plus or minus since we're solving. Opposite of adding is subtracting, so now I have x equals negative 5 plus or minus 7. Break that up, so that tells me that x equals negative 5 plus 7, so that gives me x equals 2. And x equals negative 5 minus 7, so x equals negative 12. And there are my two answers. Now, what happens if our a is not 1? Well, start off the same way we just did. So we're going to take the coefficient to the other side. So that gives me 2x squared plus 10x equals 6. Now, our rule with completing the square was when x squared was just x squared. So whatever the coefficient in front of x squared is, you need to factor that out. So in this case, it is a 2. So if I factor that out, that gives me x squared plus 5x equals 6. Now the b is 5. So off to the side, I have 5 over 2. Well, that's going to be a decimal, and I don't want to use decimals, so we're going to take that and square it. 5 squared is 25. 2 squared is 4. So now I have 2 times x squared plus 5x plus 25 over 4 equals 6. Now, here's also a new part, because when the a was 1, you really were only adding that new term to the other side. But now, you have to remember to multiply whatever you factored out there. In this case, it was a 2. So we have to multiply 2 times 25/4, and that's what we have to add to the other side. So 2 times 25 would be 50. So that would be 50 over 4. Now the right side is a perfect square trinomial, so that would factor to 2 parentheses x plus 5/2 squared equals, if you type this in your calculator and convert it back to a fraction, you will get 37 over 2. Opposite of multiplying by 2 is dividing by 2. So that's going to be x plus 5 over 2 squared equals 37 halves divided by 2 just gives me 37 fourths. Now I have to take the square root of both sides. So that just gives me x plus 5/2 equals plus or minus. You can break this up. The square root of 37 can't be simplified, so I'm going to leave that. Square root of 4, though, is just 2. So now we need to bring the 5/2 over, so the opposite of addition is subtraction. So that gives me x equals negative 5/2 plus or minus the square root of 37 all over 2. And you can leave your answer like this. Let's try another one. So the first step is to move the coefficient of c to the other side. So that gives me 2x squared plus 6x equals 7. Factor out your a. So it's going to be 2 times x squared plus 3x. Your b is 3, so 3 over 2 would be a decimal, so I don't want the decimal answer, so I'm going to leave it as the fraction and square it. So that gives me 9 over 4. So now I have 2 parentheses x squared plus 3x plus 9 over 4 equals 7. But what we have to add to the other side is actually the product of 2 and 9/4. So that would be 18 over 4. So now I have 2. This is a perfect square trinomial, so that's going to factor to x plus 3/2 squared equals, if you type this in your calculator and convert it back to a fraction, that gives you 23 over 2. Divide by 2 on both sides, so I have x plus 3/2 squared equals 23 over 4. Take the square root of both sides, so that gives me x plus 3/2 equals plus or minus, can't simplify the square root of 23, but the square root of 4 is 2. And then subtract the 3/2 back to the right side, so that's going to be x equals negative 3/2 plus or minus the square root of 23 over 2. And that's where your answer can be left. Now, the next slide just kind of summarizes the steps that we just did, where we collected the variable terms on one side and the constants on the other, divided if we needed to make the a squared term, the coefficient in front of the a squared 1, completing the square, factoring it, taking the square root, and solving for the variables. Vertex form of a quadratic is y equals a parentheses x minus h squared plus k, where h and k form your vertex. So in this example, we want to go from the standard form to the vertex form, and then also identify where our vertex is located. So to do this, we have to complete the square. Okay, you can change the function notation to y if you want to. However, it's not really going to affect it in the end, so I'm just going to work with it as it is. So our first step would be to take the c and move it to the other side, so that means that I'm going to add 1 to both sides, so that becomes h of x plus 1 equals x squared plus 7x. Now complete the square, so our b term here is 7, so 7 over 2 is a decimal answer, so I don't want that. Let's square that, so that's going to be 49 over 4. So now I have h of x plus 1 equals x squared plus 7x plus 49 over 4. But remember, what I added to the one side, I have to add to the other, so that 49 over 4 has to go on this side as well. So in my calculator, 1 plus 49 over 4 converted back to a fraction, that would give me h of x plus 53/4 equals, this is a perfect square trinomial, so that factors to x plus 7/2 squared. And then the last step is to move this constant back over so that you have your k value. So that gives me h of x, opposite of addition is subtraction, equals x plus 7/2 squared minus 53 over 4. And then you can identify where your vertex is. It's the opposite here, so since that's a plus 7/2, that tells me my h value is negative 7/2, and the k value is negative 53 over 4. Let's do a couple more. So we have f of x equals 2x squared plus 12x plus 13. So I'm going to move the 13 to the other side. So that gives me f of x minus 13 equals 2x squared plus 12x. So I need this to be just x squared, so that tells me I need to factor out a 2, so that gives me f of x minus 13 equals 2 parentheses x squared plus 6x. Now my b is 6, so off to the side, 6 divided by 2 is 3, and 3 squared is 9. So that tells me that I have f of x minus 13 equals 2 parentheses x squared plus 6x plus 9. But remember, I still have to add something to the other side, and that something comes from multiplying these two. So 2 times 9 is 18. So that gives me f of x, negative 13 and positive 18 makes positive 5, equals 2. This is a perfect square trinomial, so that factors to x plus 3 squared. And then the last step is to move your k back over. So you have f of x equals 2 times x plus 3 squared minus 5. And your vertex is at negative 3, negative 5. Let's try one more. G of x equals 3x squared minus 9x minus 2. So I'm going to take the 2 to the other side, so that gives me G of x plus 2 equals 3x squared minus 9x. Factor out my 3, so that gives me G of x plus 2 equals 3 times x squared minus 3x. The b is negative 3, so off to the side, negative 3 over 2 would give me a decimal, so I don't want a decimal, I'm just going to take that and square it. Negative 3 squared is 9, 2 squared is 4. So that gives me G of x plus 2 equals 3 times x squared minus 3x plus 9/4. Again, remember that you have to multiply these two numbers to add what you need to the other side. So 3 times 9 is 27. So we're going to add 27 over 4. In my calculator, 2 plus 27/4 converted back to a fraction gives me 35 over 4. This factors to 3 times x minus 3/2 squared. And then move that number back to the other side. So we have G of x equals 3 parentheses x minus 3/2 close parentheses squared minus 35 over 4. And our vertex is at 3/2 negative 35 over 4. Okay, let's review for a minute. It says, write the quadratic equation in standard form, and this is already in vertex form. So that can be rewritten as f of x equals 2. There's 2 of these, so that's going to be x minus 4 times x minus 4 plus 5. So that gives me f of x equals 2 parentheses. FOIL this out, and you will get x squared minus 8x plus 16 plus 5. Distribute your 2. So that's going to give me f of x equals 2x squared minus 16x plus 32 plus 5. And then lastly, combine your like terms of 32 and 5. So that gives me 2x squared minus 16x plus 37. B, so we're going to rewrite it with the x plus 8 written out twice. So that gives me f of x equals 1/2 parentheses x plus 8 times x plus 8 minus 2. So that gives me f of x equals 1/2. FOIL this out, and that will give you x squared plus 16x plus 64. Distribute your 1/2. So that gives me f of x equals 1/2 x squared plus 8x plus 32 minus 32. And so our final answer would be f of x equals 1/2 x squared plus 8x plus 30. Okay, our last example says, using the graph, write the quadratic equation in standard form. There are 2 methods that you can use to approach this. The first method is using your x-intercepts. So that's the way I'm going to do it first. So the first step, if you do it this way, is to find your x-intercepts. So if I look at the graph, it crosses at 6 and negative 2. So we have x equals negative 2 and x equals 6. The next step would be to write your factors out based on your x-intercepts. So if x equals 2, that tells me that one factor is x plus 2. And if x equals 6, that tells me the other factor is x minus 6. Then the next step would be, does it open up or does it open down? And if you look at the graph, it opens down, which tells you there has to be a negative out front. So then really what we have is negative parentheses x plus 2 times x minus 6. And then from there, you can just FOIL that out. So that gives me negative parentheses x squared. Positive 2 and negative 6 is going to give me negative 4x. 2 times negative 6 is going to be negative 12. Distribute your negative. So that tells me that my equation would be that f of x equals negative x squared. A negative and a negative makes a positive 4x, and a negative makes a positive 12. And then because this is in standard form, that tells you that it should cross the y-axis at positive 12. And if you go to your graph, it does indeed cross at positive 12. So that's the first way of doing it. If for some reason this doesn't come out to be it, then you may need to multiply the whole equation by something to make that value what it should be. Like for example, if this number should be a 6, then I would need to divide everything by 2. And you would have a 1/2, a 2, and a 6. The second method, so that's method 1, if you choose to do it that way. The second method, first thing you want to do is to find your vertex. So in this case, the vertex would be at, looks like it's at 216. Then you know, again, to look and see, does it open up or does it open down? In this case, we know that it opens down, so we know there needs to be a negative out front. So since we're using the vertex, we know to write our equation in the vertex form, which is y equals a parentheses x minus h squared plus k. So this would give us y equals, we know that a is a negative, the h is 2, and k is 16. Now expand this out like we just did in the previous two examples, so that would be y equals negative x minus 2 times x minus 2 plus 16. So that gives me x squared minus 4x plus 4. Distribute the negative, so that gives me negative x squared plus 4x minus 4, and then you have your plus 16. Collect like terms so that you had y equals negative x squared plus 4x plus 12. And again, you would check to make sure that that is your y-intercept. If it wasn't, then you could multiply everything by something so that the c value came out to be the same.